Hello everyone and welcome to another Zotin session. How about that? Bet you expect that shit to happen. So today is the second day of doing Advent of Code in the God's Temple. So in the previous session, I probably need to create like a playlist for all of the TempleOS sessions. So let me actually put myself some sort of a reminder. Advent of Code in TempleOS to be done. Right, so in the previous session, we set up the development environment, right? So we created a bunch of scripts to set up the QEMA virtual machine with the TempleOS instance and stuff like that. Off screen, I spent some time actually cleaning up those scripts and organizing everything, and I put them into this GitLab repo. You can find the source code, you can find those scripts right in the description right here. And let's actually take a look at them. So essentially what you have 5 shell scripts. The first one is the configuration. This script you're not supposed to run, right? So it's just like basically a list of parameters that is used by all of the other scripts, right? So, and you want to use the rest of the 4 of them, right? So we have install.sh script, which basically creates the installation of TempleOS. We have a mount.sh script, which mounts the file system of the TempleOS into the host file system, so you can exchange the files between host operating system and TempleOS. We have run.sh, which essentially runs the QEMA virtual machine with the TempleOS instance and stuff like that. And we have a sync script, which basically syncs the folder with the solution between the TempleOS and the host system. And in fact, you can use it to sync it both ways, right? If you made some changes in the host folder with the solutions, you can sync them into the TempleOS. And if you made some changes in the TempleOS, you can sync them back into the host system. And you want to sync them back into the host system because that's what we're going to be committing into this repo. We're not going to be sharing the actual, drive, right? So I'm going to be sharing essentially this folder that I sync out of the TempleOS instance. And because of that, I can quite easily recover the TempleOS instance if I, for instance, break it for whatever reason. So this is actually quite convenient. For instance, I have this image, half of a gigabyte image, and I don't really need it anymore. I can straight up remove it, right? So it's not needed anymore. Right, so should I fetch the latest changes? I think I want to try to fetch the latest changes. I think I already did that. Right, and now I can quite easily create a new installation. So I need to run install.sh script, but I have to provide the name of the image, right? So you can actually have several images if you want to. It's going to be AoC 2021 image, and it will create that image and it will start the virtual machine with the TempleOS. The ISO of the TempleOS is included in the repo. It's actually quite small. It's 17 megabytes, so it's not going to be that huge of a dependency to download, so I decided to just commit it into the repo, and I don't plan to change it at all. Usually the binary files in Git create problems when you change them a lot because it cannot store the differences between the binary files, as far as I know. Please correct me if I'm wrong. And essentially every time you modify the binary file, it creates like a copy of it. I think this is how it works, right? So if I put like a single small binary file into Git repo and I never change it, I think it's not going to create that much problem, right? Again, please correct me if I'm wrong. So anyway, here I have TempleOS ready for installation, and I just say yes, and it will spend some time installing everything, right? And while it's installing, let's actually make a cut. And no, this is not how we make a cut. And we're done installing this thing. So it suggests to reboot the operating system. We're not going to reboot anything. We're going to answer no. And I'm going to just straight up close the virtual machine. So after the installation, we have our image, which we can go ahead and run. So I also have to provide the password because it tries to unmount some systems and stuff like that. And let's go ahead and load this entire thing. So it will take some time to uncompress a dictionary. I have no idea what is a dictionary, as I already said in the previous sessions. Like it's, I don't know, maybe it's a dictionary of all of the functions or something like that, but it's uncompressing it. It's going to take some time. So maybe we should cut it. Let's go ahead and cut it. So it's almost done uncompressing the dictionary, and there we go. We are ready to use our freshly installed TempleOS system. It's not going to do that every time you start it. It only does that for one single time after the installation. So if I just like close this entire thing and restart it one more time, it's going to just start the TempleOS and not going to uncompress anything. So it's just like one-time event. So, but in here, we don't have our advent of code solutions. So we need to sync them into the Temple. To do that, we have a sync command. It accepts the subcommand host or temple, and host or temple depends on your target, right? What is your target? We want to sync the solutions into our temple, right? So that means the subcommand is going to be temple, where the destination is the temple. And I also provide the image, and it will basically mount everything, and it will use our sync to sync the solutions into the temple, and then I can run my TempleOS installation, and the solutions should be there, right? The solution should be there. Okay, so there we go. Here are the advent of code solutions. I can open that. Here is the first day, and here is the source code of the first day. There you go. So we basically recovered the TempleOS installation, right? So, and I can make some changes in this thing. Let's actually say something like hello from God's temple. And I'm going to save this entire thing, and I'm going to quit the whole virtual machine. After that, I can quite easily just sync it into the host, right? And if you take a diff, you will see that now we have the line that we added in the TempleOS. Right, here's the interesting thing. I already noticed that in the previous session, but TempleOS constantly inserts this Control-E symbol. And what I recently learned, it's the TempleOS way to remember what was the last position of the cursor. Right. So essentially, when it opens a text file or source code file, and it puts the cursor in this place, which is kind of an interesting feature, right? So it doesn't store the last cursor position somewhere outside, so it not disturb the file content or anything like that. So the cursor is part of the file content. So it's kind of interesting and weird at the same time, but we don't question divine intellect on this channel. Okay, so it is what it is. Right, and after that, I can quite easily just commit the changes that I've made in TempleOS, right? You see? So I just do add, and let's do something like add message from the God's temple. Unfortunately, I can't use these single quotes in here, right? So I have to use double quotes, and then I can push that right into the repo. And this is basically going to be our workflow as we solve the problems. Push origin master. Okay, so that's pretty cool. So it's going to take some time. And let's start the God's temple one more time. AoC. There we go. So, and I suppose let's go ahead and create the folder for the second day. Right. So I'm going to go there, and I'm going to do dir mk 02. Right, so that should create the folder 02. I'm going to go into that folder, and I'm going to open the editor main.hc. HT stands for Holy See, of course, and there we go. We have the thing. So one of the things I started to do with my solutions, I started to CD to the folder where the solution is located, so I can use the relative paths and stuff like that. I'm not sure why I have to do that, but this is something that I have to do. Right, so here's the home, AoC 2021 02, and there we go. So we are inside of this thing. So, and then I'm gonna probably create part 1 function. Part 1, because usually there are 2 parts, and I'm going to just run it right away. Maybe I should put semicolon in here. Let me save everything and let me try to run it, and everything seems to be running. I'm really happy about that. Okay, let me close this entire thing, and let's go ahead and read the second day. How about that? So I haven't read anything about the second day, so this is going to be yet again my first reaction to this problem. So let's go ahead and read it. Day 2, dive. Now you need to figure out how to pilot this thing. It seems like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X increases the horizontal position by X units, down X increases the depth by X units, and up X decreases the depth by X units. Okay, so we can go forward, horizontal position by X, then up and down. So I suppose it's like in two-dimensional, right? So, okay, I see. Know that since you're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. Wait a second. Since the submarine down and up affect your depth, so they have. If you go down, it increases the depth. Okay, but how do you know what I might expect? So. Okay, the submarine seems to already have a planned course, your puzzle input. You should probably figure out where it's going. For example, forward 5, down 5, forward 8, blah blah blah. Your horizontal position and depths both start at 0. The steps above would then modify them as follows. Okay, forward 5 adds 5, down adds 5 to depth, okay, forward 8, blah blah blah. So, and that's the final result. After following these instructions, you would have a horizontal position of 15 and a depth of 10. Multiplying this together produces 150. Okay, calculate the horizontal position and depth you would have after following the planned course. What do you get if you multiply the final horizontal position by the final depth? This sounds actually pretty straightforward, so let's actually go ahead and implement that. So it's going to be very interesting how we're going to... Oh boy, how we're going to parse this entire thing, right? So I suppose... should be relatively straightforward, right? So we can create a function that basically accepts the string and skips the characters until it encounters space or something that is not alphanumeric, right? So, and it also returns maybe the size of that string, and then we can use it to compare with predefined strings and whatnot, right? So, and then we can use str to i64 to parse the numbers and stuff like that. So that should be pretty straightforward, I do believe so. All right, so maybe I need to go ahead and mount the instance and put the, you know, the sample data into my second solution. So this is going to be AoC. Here's the second one, and let's do something like sample txt. I usually prefer to use ed for copying data, right? Though this is yeah, I think I'm gonna use ed for this one, right? So I'm gonna start in the insertion mode. I'm gonna copy paste this entire thing, and I'm gonna basically commit and save this entire stuff. So here is the sample txt. Cool. So let's go back and run our virtual machine. Take it or no. So let me see. Boom. So here's the second one, and here is the sample txt. If I open sample txt, here is the sample txt. Everything pretty straightforward. So I'm gonna just close this entire thing, and I'm gonna open HC in here. So as we learned last time, the easiest way to read the file is to use the file read function, which reads like literally everything. File read. Yeah, it's actually a pretty cool function. I wish I could just jump there, but I can't. Okay, there we go. So it accepts file name, this, and the size. So that's the only things that we probably need in here. Okay, so I didn't really want to modify this entire stuff. So file name is going to be basically sample txt, and the expected size we're going to provide like so. Let me also define the size somewhere here. Was the size i64? I already forgot. I think the size was i64. I wish I remembered that. It is in fact i64. Okay, so that's cool. So here is this size. So what I need to learn now is to how to parse numbers. So I need some sort of a way, I need some sort of a function, right, that accepts the pointer to the string, right, to the pointer to the start, or maybe, well, let's call it str, Can I just close this one? This is really, really annoying. I think you can open it by pressing Control Alt F1 or something like that. I don't quite remember, but I don't remember how to open it back. Okay, so this is going to be the string, and I suppose the size of the parsed word, right, of the parsed word is going to be, you know, provided here as well. And the result of this thing is going to be the pointer to the end of the word. Though it's kind of interesting, since we know the beginning of the word and the end of the word, maybe we don't really care about the size. Yeah, the size doesn't really matter. Yeah, we don't need the size at all. Can I just delete this entire thing? How can I could probably do Control-C. Okay, that's cool. Right, so we can figure out the size of the word by just by subtracting the end, begin from the end. So let's call this entire thing something like parse word. And we need to implement that somehow. So the question is how we're going to implement this entire thing. Just a second. Oh yeah, this is how you bring it back. You have to press Control Shift F1. Yeah, that's how we do that. So we can close that, Control Shift F1, and it brings it back. Okay, that's actually perfect. Because this window is really annoying, and I finally learned how to bring it back when I need to. It's really weird combination of keys. Control Shift F1. It is really inconvenient to type. I don't know, maybe Terry had like really big hands or something. So anyway, what we're gonna do, is there something like is alpha, because like in, you know, in pure C, there are things like is alpha, is digit, and stuff like that, but maybe it doesn't really matter because I can actually do that myself. Right. So parse word. While str is actually between a and z, we're gonna increment it. Yeah, we're gonna simply increment it. So I probably can do something like str++. As soon as it's not, we basically parsed the word, so I can just return the str as the end. So that's pretty straightforward, I think. Okay, so that's cool. Now, while size is greater than 1, what I'm trying to do is I'm trying to parse a word. So we're gonna have something like this. U8 word end parse word. Parse word, and we have to provide the beginning, so it has to be somewhere here. So this is going to be str. In fact, I like to do the following thing. I'm going to have a beginning here, right? And I'm going to keep the begin, so later I can actually free it, because file read uses malloc to allocate the memory to read the whole file, right? So we have to use something like free begin. There we go. So that should be fine. Right, and then I'm going to have a separate variable to store the iterator. Right, so this is going to be something like str, and it starts at begin. Okay, so we found the word end, right? We found the word end, and it's supposed to be a pointer. And now I need to compare the parsed word with something, right? So I need to compare it with something. Can I do basically strcmp? I remember there was some sort of strcmp. There we go. This is what I'm talking about. Compare to strings. So this is probably what we need. But here's the thing. It probably compares null-terminated strings, right? And we don't really have implementation in here. But I would presume that it compares null-terminated ones. There is strncmp. Compares n bytes into strings. But ignoring keys and stuff like that. So I'm not really sure what exactly it's doing though. Though, here's the cool thing. We know that the data is valid, right? And up, down, and forward have different sizes of the words. So, we can quite easily basically take the size of the word and dispatch upon the size of it, right? Up has 2 characters, down has 4 of them, and forward has 7 of them. So we don't even have to compare the strings in here, right? So here's an interesting thing, right? I don't really know that language, this language too much, and it's a very simple language, and it kind of forces me to think about simple solutions. Right, so yeah. What I can do now, I can do something like n. I can take the word end and subtract the beginning of it. And there we go, I have the size of the word. And in here, I can basically dispatch, right? Can I do switch n and essentially dispatch on different sizes of the words? Right, so this is going to be something like case 2. So this is basically up. Right, so I don't remember how to work with switch cases, and I'm too scared to look up the YouTube tutorials on that. So let me see. So this is going to be down. This is going to be 4. Right, so this is down. I hope they work the same as in C. And for the forward, so forward 1 to 3. It's actually 7. I already said that it's 7, but yeah. So this is forward, and here we're gonna break. And here we have an unreachable situation. If it's something else, this is straight up unreachable. And I don't really know how to throw an exception. There is such thing as throw, which is kind of alarming. So does the Holy C support exceptions? Can be up to 8 characters, like in the catcher, fetch. Okay, so apparently there is some sort of exceptions in here, but oh right, maybe I would like to have something like assert. Is assert a thing? Assert. Looks like it is, but I'm not 100% sure. Right, so can I have false or maybe... Yeah, maybe I should look it up. Holy C, assert. Okay, so, welp, there's no useful information about that because Google doesn't even understand what I'm asking. Okay, so let's actually not do anything in here. Maybe I could print something unreachable, right, and we can print the n like so, right. Unreachable. I don't even know how to throw an error. I probably need to research how to do that. Okay, so here's up and down and stuff like that. And I suppose now I need to parse the value, right? So I need to parse the value somehow. So to do that, I need to assign word end here. And then try to do str to I64, right? str to I64, and I remember it accepts the beginning, then the radix, and then the end, right? So it accepts the end. Okay. Oh yeah, I just remembered. So it's better not to put variables in here, right? So yeah, it's better to actually pre-allocate all of this stuff like up front and just put it in here. So maybe, so here is the end. Let's call it end p because again I'm gonna reuse for both of the cases. So so parse word. Let me grab this thing. Oh man, this is really annoying. So I still need to have these things in here, right? But I need to get rid of the declarations, right? So let's get rid of the declarations of our nations. And I also need to get rid of this stuff. I wish I could just use Emacs. Because yeah, this text editor is unbearable, but maybe after a month of using it, I will finally get used to it, but right now it's just like pretty much unbearable. So str, well, str has to be begin. Oh my god. Okay, it's gonna be begin, and there we go. So I parse, here's the end, and then I need to compute end. Okay, so that's what I have to do. So this is gonna be this thing. And I don't even know how to jump to the beginning of the line So I have to use my mouse to do that. All right, so that looks fine. Cool. So parse word, here is the size, and then I assign the end, so it has to be end p. All right, so here is end p. So end p, and I have to go here. This one is gonna be end p. Let me close this thing for a while because it's very annoying, and it's also blinking like hell. Holy shit. Okay, so here's this stuff, and we get the end pointer after that. So maybe it would be nice to remove this line and actually separate it. So here we basically parse the word and we extract the value out of it. And the next thing we have to do, we have to basically parse the number or something. So this one is going to be x equal, and then we have to reassign and back to the str, right? And back to the str. So this is basically how we parse the entire thing. And we also have to keep track of this like size thingy. So yeah, I have to be a little bit careful with that. So okay, I have to do size minus end p minus str before I can assign this entire thing. And then here's the size minus end p minus str. There we go. So here we parse the word, and then we parse the value, and then we are ready to do the dispatching. Okay, so that's cool. Hopefully. And we probably need to keep track of the depth and the horizontal position, right? So horizontal position is basically x and depth is y. Maybe we can keep track of x and y, but already use this thing. So let's actually do something like this. So it's going to be I64, position and depth, right? Both of them at the beginning has to be 0, right? Both of them are 0. So if we're going up, right? If we're going up, we take the depth and we subtract the x value out of it, right? So up decreases your depth by 3. So do they even say anything about the depth becoming negative, right? Because that means you hover above the surface or something like that. Anyway, so here's the depth. Then we have down situation, depth plus x. And then we have a forward situation where we take the position and increment it by x. Okay, so that's pretty cool. After that, what we have to do, we have to multiply them together and print the final result. Okay, so let me try to do that. Part 1, d, and it's going to be position multiplied by depth. And that should be it, essentially, hopefully. I'm not sure. Let's try to run this entire thing. And it's 150. Did I first try the entire shit? Just a second. I need to ungrab my mouse. Yeah, it's 150. And it's the sample data. Okay, so... yeah, well, I mean, it's a pretty simple and straightforward problem. So what did they expect? So, yeah. I had to do this stupid hack because I'm too lazy to figure out how to compare strings, and luckily each individual string in here has like a separate length. I could have actually even used like a first character, right? So I don't even have to like take a look at the length or anything, but yeah. That's pretty cool. So I suppose what we have to do now is get the input data. So let's take our puzzle input. How many things do we have in here? We have quite a lot of things in here. Look at that. All right, so let's go ahead and mount AoC 2021. Right, so it forgot my password already, and I'm gonna go in here. So mnt home AoC 2021 and 02. So in here I'm gonna do input.txt, right? And I'm gonna start the insert mode. I'm gonna copy paste the entire thing and save it. There we go. 7,757 characters, so basically bytes. All right, so I'm gonna quit that, and here we have the input txt. Cool. So after that, I'm gonna go back and I'm gonna run the virtual machine, and the sample data should be already available there. We'll see. We'll see if it's there. So there we go. AoC 2021. 02, and here is the sample data. Let me take a look. This is not the sample data, I mean the input data, right? I meant the input. Here is the input data. Okay, that's cool. So let's go into the solution, right? So I'm gonna just increase this entire thing and we'll get rid of that annoying window, like holy shit, and we're gonna try to do the input and see if it's not gonna break our entire operating system, hopefully. So we've got an unreachable situation. That is very cool. This is because we got 0 a couple of times. I'm really glad that I actually put that unreachable in there, right? Because that is really, really sus. I wonder why I got the 0 in there. So that means n straight up turned out to be 0. Why would it be 0? So we can try to also, you know what, I think we should also try to break on that thing. Can we? We should try to return, right? Though it will kind of leak a little bit of memory, but who cares, right? So let me see what we can do in here. So it basically fails on unreachable, but we don't really know if it actually does anything. So let's do a little bit of tracing, right? So when we encounter up, we're gonna say up, and we also want to print some the value that we're going up, right? So in here we're gonna print down, right, down, and then we're gonna do that because I want to see how many like lines at least we're handling, right? So the sample data works, but input data for some reason doesn't really work properly. Maybe forward doesn't work properly. I don't even know, to be fair. It's like really bizarre. It's really bizarre to me. Okay, so we did forward 7, and then we reached the unreachable, which is kind of sus, not gonna lie. So maybe it has something to do with that pesky cursor thingy. It could be the case. But I'm not 100% sure. So it straight up like fails after the first forward, I think. Right, so let me take a look. So it does forward 7, but then it fails to go on the next line. All right, so let's go ahead and just take a look at the file, at the input file. So I'm gonna mount AoC 2021, right, there we go, and I'm gonna go into the MNT home AoC 2021. So I also have to go to the second day, and let me take a look at the input. So what do we have in here? We don't even have anything special, right? It just fails to handle the new line for whatever reason. Just fails to handle the new line, even though on the sample, right, if we take a look at the sample, it didn't fail to do that. Right. So let's go back and try to solve the sample yet again. Run AoC 2021. Okay. That is really sus, not gonna lie. So I'm gonna go to main to HC, and I'm gonna do that. So let's go back to the sample and let's run the sample. So with the sample, it's also failed, but it worked. Did I change something? I don't remember changing anything. What changed? It just worked, and now it stopped working. That is really strange. Like, what the fuck? Why would it stop working all of a sudden? That is absolutely bizarre to me, to be fair. Right, so here we do end P, so I don't see any errors in here, and then Here is the size of this entire thing. Okay, and then I subtract the size and the end becomes the new end. Okay, that's fine. Then I do this thing where I also get the end and I subtract the size and the string becomes new end. Right, so then I dispatch upon these things and I change things accordingly, right? And then if the default unreachable, I just return saying that you found something fishy in here, and we have to keep doing that. We just don't, and it used to work and it stopped working even for the sample. It's kind of strange. All right, so let me try to maybe trace the size, or maybe I don't really know. So maybe I'm missing something very, very important. So let's try to do size. Here is the size, and let me try to trace that. Size 49 and size 40, and it just became unreachable. It just became unreachable. So size, though, wait a second. So this is a sample. Size 9, right? So the size was 9, and if I take a look at this thing, so if I take a look at the sample, was it really 9? 1, 2, so this is 7, 8, 9, and then we set it to new line, which is really strange. Should we do that? So, because I would expect str to i64 ignore that new line. You see what I'm talking about? I would expect it to ignore that line. So that is really strange. Why wouldn't it ignore that line? And in the previous solution, if I go into here, for instance, right, so can I just go back? Right, so and then I go to cd 0, 1, and if I just take a look at the solution in here, this is not really what I wanted, but I wanted something. It's really difficult to click on these things. Okay, so I'm doing the same thing in here. Well, wait a second. Some digits. I'm sorry. It's so hard to click on them. But at the same time, it's the fastest way to navigate in this entire thing. Okay, right, so what I'm doing here is just I'm subtracting this thing and I'm setting str to end p. So everything should be fine. Everything should be fine, but it... Oh, wait! I understand how it works. Yes, okay, because our parse word does not ignore the new lines. Okay, so the problem here is that parse word only looks for the alphanumeric characters, and it's incapable of ignoring white spaces. This is fine. The question is, how the fuck did it work the first try? This is really sus. Okay, now I understand why it doesn't work. I understand why it doesn't work. Why did it work the first time when we didn't handle that? So what's so special about, like, that is so weird. Okay, so maybe for the parse word, we probably need to first skip the spaces, right? So while this one is really interesting, right? So I have to probably do something like skip white spaces. U8 skip WS, right? So, and I'm gonna take this thing and it's gonna be str. Right, so boom, 1, 2, 3. I don't know why I do 3. So while str is equal to space or str equal to new line, and I guess that's it for now, right? So that's it for now. So maybe we're gonna add more in the future, but for now we're gonna only use that. All right, so right before we parse the word, I think I'm gonna just say skip WS, right? Skip WS, and that will skip this entire thing. Right. Is that a good idea to do that? I actually doubt that it's a good idea to do that. Because because yeah, it complicates everything. It actually complicates everything, so we probably don't want to do it this way. So yeah, because I need to also skip this entire thing. I want to actually extract the state of str and size into its own separate structure. I need to develop my, I need to port my string view library to TempleOS, to Holy C, yeah. So I have a string view library that I use in C all the time, and I feel like I kind of want the same thing, but for Holy C now. So I'm going to put that in the description. But the whole idea here is that you have the structure, which is basically count plus the pointer, right? And then you have a bunch of operations that operate on that count and the pointer, slicing things and parsing things and trimming things and so on and so forth, right? So I kind of want to recreate that in TempleOS. Maybe I'm going to just create such library, like a similar one, and use for my Advent of Code solutions at some point. So that will be actually kind of interesting, because that would simplify a lot of things that I'm trying to do in here. Right. But I need to master the editor a little bit better, because this editor is absolutely painful. Holy shit. All right. So after this end, I suppose I can try to skip that new line manually, right? So I subtract +1 in here, and I actually do +1 to move to the next character. So this is one of the things I can do at least, right? It's not ideal, but it's just at least something, right? So it's not the prettiest solution, but it is a solution nonetheless. Okay, so we are pointing to a sample, so let's take a look if it works, and there we go. So the part 1, 150, and here is the trace, and everything seems to be working correctly, right? So, but why again it worked the first time? Did I like make a typo and accidentally make it skip that new line? Maybe, who knows? It is going to be a mystery for the rest of our lives. Though everything is recorded, so maybe I can go back and see what exactly I typed in there, but I'm not going to do that. Okay, so the solution in here is supposed to be 2036120, hopefully. So the last thing in here is forward 5, forward 7, forward 1. Let me actually confirm that that's the thing. So if I go down, forward 5, forward 7, okay, so that seems to be all right. So let's try to submit that. So 203, right, 203, 612, 612. Oh, let me double check. 203, 203, 612. Oh, okay, we're gonna submit that, and first try. Cool. Oh boy. So the lack of the convenient data structures and operations, and also the unbearable text editor. Well, I mean, I just need to get used to the text editor. Makes it more difficult than it should have been, but I think I'm getting there. So yeah, that would be kind of cool. So can you have like structures in Holy C? If I remember correctly, the struct keyword in Holy C simply does not exist. You have to use like a class. Yeah, so essentially the classes in Holy C, they have the same semantic as structures in C, but it's just like there's no struct keyword. They're called classes. Okay. So it is what it is, and it isn't what it isn't. So what I'm thinking is that we can just create string view, and a string view is essentially going to be, I think I have to like put here, this thing in here. It's going to be I64 count, so that's the size of the string view, and U8, you know, begin, I suppose, and then we need to implement some operations on this entire thing. So like chop word or chop by white space, and that will create like a new. Wait a second, that requires kind of like passing structures and classes by a value, and I heard some rumors that it's kind of like doesn't work in Holy C. Right. So passing stuff by passing structures by value is not really a thing that reliably works in AoC. So I'm actually not sure. But I mean, you can always pass things by reference, right? So it's not that big of a deal. Anyway, so we have solution for the first problem. So let's go ahead and see. Let's take a look at the second part. Continue to part 2. Okay. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which is also stats at 0. The command also means something entirely different that you first thought. Down X means increase your aim by X units. Up decreases your aim by X unit. Forward does two things. It increases your horizontal position by X unit. It increases your depth by your aim multiplied by X. Again, note that since you're on a submarine, down and up do the opposite of what you might expect. Why are you even telling me that? It's like you almost intentionally like priming me for a failure or something. Like, you're not making it more clear. You're actually making it more confusing. Like, stop. Okay. Now that above example does something different, forward 5 adds blah blah blah, so this is basically a log of what you need to do. After following these new instructions, you would have a horizontal position of 15 and depth of 16. Multiplying this produces 900. Using this new interpretation of the command, calculate the horizontal position and depth you would have after following the planned course. What do you get if you multiply the final horizontal position and the final depth? Okay, so but you don't have to multiply it by aim or anything. So aim is sort of like a hidden variable that is used to modify the horizontal position and the depth. Okay, that is all right. That is okay. So what I'm probably gonna do, I'm gonna comment out the part 1, right? So this is gonna be part 1, and I'm gonna copy paste the part 1 into part 2, right? Because I'm gonna reuse a lot of code in here, right? But I can't reuse everything, right? I can't reuse everything. So we're gonna start with the sample, right? So here's the sample. And as they already mentioned, we also have aim. Go away, please. Go away, please, please. Thank you. And I accidentally closed everything. Okay. So this is part 2, and we also have aim, which is also 0. Okay, so do I need to keep track of the size? I don't think size is particularly useful, so I'm gonna just like yoink it. Cool. So let's modify this entire stuff. So down X increases your aim by X units. Okay, down X. So we're gonna do aim. We are increasing aim. Up decreases your aim by X unit. Okay, so up decreases my aim, whatever that's supposed to mean. And forward does two things. It increases your horizontal position by X units, right? So yeah, we increase the horizontal position by X units. And it increases your depth by your aim multiplied by X. Okay, so let me see. We're gonna do depth. Multiply by aim, multiply by X. Did I do that correctly? Depth by your aim multiplied by X. Okay, so this is literally what we've done so far. Okay, so, and the rest of the stuff is going to be the same. So it's a part 2 and position multiplied by depth. So, and I probably need to call the part 2 function. Part 2, and let me go ahead and do that. Okay, so for the sample, it's 900. Which is exactly what we would expect. Okay, so let's actually change that to the input. We're changing that to the input and a boom. So the final result seems to be 2015. It looks like a date of some sort. I hope I didn't reach any overflow, though I shouldn't, I think. I think there should be no overflow because I'm using like 64 bits or something, but it's kind of like a little bit sus, right? It's a little bit sus that it's so huge. Though, I have an idea. I can do something like, yeah. I can try to trace it and see if it produces anything that resembles overflow. And also there are some ways to check whether like position multiplied by depth overflow or something. Let's actually print them separately, just in case. I don't know why I'm so paranoid about that, because that's a very common error in here, right? So depth, I'm gonna actually print them separately. And okay, so they don't look like they would overflow, I think. That looks fine, more or less. Yeah, it looks fine. So let's go ahead and just like remove this entire thing. Though I don't really have to remove that, I just need to retype the final answer. Okay. So the sample work, which is nice, 2015, 5477, 16. Okay, 2015, 5477, 16, and boom, we solved the second day. How about that? How about that? Bet you didn't expect that shit to happen. That's pretty pogue. All right, so let's remove that. And let me quickly actually uncomment this entire stuff. And I'm gonna run both of the parts. And maybe I wanna get rid of the tracing, you know? It's kind of like tracing is not really helping right now. It was useful for debugging purposes, but now it is not particularly useful. So I wonder if there is like a step debugger in the TempleOS. That would be kind of interesting. Right, so there we go. So there's also this stupid tracing of sizes, which we also should get rid of. And there we go. So here's the part 1 and here's the part 2. That's pretty cool, not gonna lie. So, and now what I want to do, I want to commit my changes, right? So to commit my changes, I need to sync them into the host, right? So sync accepts two subcommands, host and temple. So I have to use host as a target and I do AoC 2021, right? It will mount everything and it will basically sync whatever changes I had in the TempleOS into the host system. And if I do git diff, well, that's kind of interesting. Oh, this is because it created a separate folder. Yeah, as you can see, here is the new folder. And I can now add AoC 2021. And as you can see, here are all of the new solutions in here. So I can do diff cached, and here are all of the code that I put in here. So it also inserts these weird characters. I don't understand what they are. Right, so the thing about TempleOS is just like sometimes it does a lot of weird things that don't make any sense. Right, so there are things between the so it's supposed to be a space, but it's not a space. All right, so that's fine. We're not questioning divine intellect. Commit add day 02. And now I can push that, push origin master. There we go. So, and this is how I'm going to share these solutions outside of the temple, right? So I have a special script that just like pulls them out of the temple. And here they are. You can watch them on, you can look at them on GitLab, or you can actually clone everything and you can kind of recreate the installation that I have with the scripts. So play with them and yeah, that's pretty much it for today, I guess. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next Advent of Code session. So yeah, love you.